Hey there, Geometry. Thanks so much for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 3.3, Proofs with Parallel Lines. Mainly we're just trying to figure out what can we use to figure out how lines are parallel and what does that mean for those angles. So we're going to be able to use the corresponding angles converse, we're going to be able to prove theorems about parallel lines, and we're also going to be able to use the transitive property of parallel lines. The first thing we're going to look at is theorem 3.5. This is in your notes what we're going to fill out. If two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So you can see that angles 2 and 6 are corresponding, which will prove that the lines are parallel. Go ahead and take a moment to pause the video here, copy that in your notes, and when you're ready to go on, click play. So what we're going to do is says find the value of x that makes m parallel to n. Well, we want our corresponding angles to be equal to one another, so that's exactly what we're going to do. We're going to write 3x plus 5 is equal to 65 and then begin to solve it. We would just subtract 5 from both sides. We get 3x equals 60. I wrote that 6 there, should have been a 5. And then we divide both sides by 3. X is equal to 20. Okay. So the value of x would be 20 for that one. Is there enough information in the diagram to conclude that m is parallel to n, and explain? If you want to try this one by yourself, pause it first, then click play to see what our answer comes up with. For this case, we would say yes, there is, because the angle next to 75 degrees is 105 degrees. Okay, so that means that 105 corresponds with this 105, and it's a linear pair. So because it's a linear pair, we know that they add to equal 180 degrees. So corresponding angles are congruent. So m is parallel to n. The next case, though, says explain why the corresponding angles converse is the converse of the corresponding angles theorem. And remember, this is theorem 3.5, what we just saw recently. The hypothesis and the conclusion of theorem 3.5 is the reverse of theorem 3.1. 3.1, if you remember, states that instead of saying corresponding angles are congruent, then they are parallel, the converse of that just says if the lines are parallel, then the corresponding angles will be congruent. So that's all that this question was having you think about. Here are a few more theorems we're going to copy down on our notes. Theorem 3.6 is first, the alternate interior angles converse. If two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. Again, what I'm underlining here should be going in your notes. The alternate exterior angle converse. If two lines are cut by a transversal, so the alternate exterior angles are congruent, then those lines are parallel. And the consecutive interior angles angles converse say that if two lines are cut by a transversal, so the consecutive interior angles are supplementary, then those lines are also parallel. Take time now to make sure you have those three theorems filled in, 3.6, 3.7, 3.8, and let's keep going to see what we've got next. Prove that if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So we're going to write a proof here. You can write it whatever way you want to, but I'm going to write a 2-column proof. All right, so we always start off with our given, which is saying that angle 4 and angle 5 are congruent based on the diagram. Then I'm going to go on and say that angle 4 and angle 1 are congruent. And I can use the vertical angles congruence theorem for that one. If that's the case, then I can also conclude that angle 1 is congruent to angle 5 using either substitution or the transitive property of congruence. So then, because I've notated that those 4 things are true, now I can prove that G is parallel to H using the corresponding angles converse. Okay. In the diagram, R is parallel to S and angle 1 is congruent to angle 3. Prove that P is parallel to Q. This one I might want to write a paragraph proof. So we start with our given. So I'm actually going to type this in a text box. So angles 1 and 2 are congruent since we are given that line R is parallel with line S. Okay. We are also given angle 1 and angle 3 are congruent. So using the transitive property of congruence, angles 2 and 3 are also congruent. We can say this is also true by the alternate interior angles converse. Line P is parallel with line Q. Okay. If you use the diagram below to prove the alternate exterior angles converse, which given and proof statements would you use? So if we are given maybe angle 1 is congruent to angle 8, right? We would just be able to prove that line J is parallel to line K, right? Now that we've looked at those things, it says copy and complete the following paragraph proof of the alternate interior angles converse using the diagram. This is also found at the top of your notes. It is given that angle 4 is congruent to angle 5. Go ahead and pause this one, see if you can fill in the blanks first. When you're done, click play. All right, angle 4 is congruent to angle 5. By the blank, angle 1 is congruent to 4. We are going to use the vertical angle congruence theorem. Angle 1 is congruent to angle 4. Then, by the transitive property of congruence, angle 1 would be congruent to angle 5. So, by the corresponding, because now angle 1 and angle 5 are in the corresponding angles, the corresponding angle theorem, G is parallel to H. Okay? The last theorem we're going to visit with is theorem 3.9, and that's the transitive property of parallel lines. That means when you have more than 2 parallel lines, then they can be parallel to the other line. So if 2 lines are parallel to the same line, then they are parallel to each other. So for example, P is parallel to Q and Q is parallel to R. That means P can be parallel to R. Remember, this is where we find the middle piece that's connecting both ideas. Take a moment to pause this video here, and when you're done, go ahead and click play so we can try our last few examples. All right, here we go. The flag of the United States has 13 alternating red and white stripes, and each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. Well, you just gotta kind of go down the list. Stripe 1 is parallel to stripe 2. Stripe 2 is parallel to stripe 3. Stripe 3 is parallel to stripe 4, etc. So we can just keep going down this list of ideas by the theorem we just talked about, the transitive property of parallel lines. Okay, we can conclude stripe 1 is parallel to stripe 13. All right, last example. In the diagram below, P is parallel to Q and Q is parallel to R, so find the measure of angle 8 and explain your reasoning. So explaining your reasoning means we're going to give the proof. So given that P is parallel to Q and Q is parallel to R, we know that P is parallel to R with the transitive property of parallel lines. Angle 1 is equal to 115 degrees by the corresponding Angles theorem. Angle 1 and angle 8 form a linear pair. So 180 subtracting 115 is equal to 65 degrees using the definition of supplementary